Hello everyone, in this video I am going to teach you generating functions and how the generating functions can be used to solve the different types of problems in discrete mathematics. Let's start with the definition of generative functions. Here, suppose we take a sequence, name sequence AN. So in this sequence we have terms A0, A1, A2 and so on, AN and so on. Means every sequence is a infinite sequence here. That's why the sequence has A0, A1, A2 and so on, AN of real numbers. By using these real numbers, we are going to write a function named g of x as a0 plus a1x plus a2x square plus and so on plus anx power n plus and so on. And this can be also written as in summation form like this. Summation n equals to 0 to infinity an x power n. Suppose we are going to take n equals to 0 in this summation a0 x 0. That's why this is the first term. And n equals to 1, we have the value a1 x power 1. a1 x power 1. And n equals to 2 in this summation a2 x square like this. Okay. And here g of x, this function g of x is called a generating function for the given sequence an whose nth term is an. Why? Because whose nth term is an is here in this expansion the coefficient of x power n is an. That's why this is the generating function for the sequence an whose nth term is an. For example, write a generating function for the sequence bn whose nth term bn is 2. We can write easily by using the generating function for this generating function with the nth term bn equals to 2. We have the general form for the generating function as n equals to 0 to infinity bn x power n. Here in the above definition an x power n. Why? Because this given sequence is an. But in this example the given sequence in the form of bn. That's why we are going to write bn x power n. That is equals to summation. Here bn value is given, that is 2. So 2 x power n is the generating function for the sequence bn whose nth term is 2. And now we are going to learn some standard generating function formulas which can be used in the problems. Now the first one is, what is the generating function for the constant sequence like 1, 1, 1, 1 and so on. So for the sequence we are going to write easily generative function as g of x 1 x plus x square plus x cube plus and so on plus x power n plus and so on. And it can be also be written as in summation form, that is an x power n, that is equals to, here the nth term of this constant sequence is also as summation 1 into x power n. So that's why we are going to expand this, we get the value of g of x like this. And this can be also be written as 1 minus x whole power minus 1 by using binomial expansion. Now the second and the above can also be written as 1 by 1 minus x. And second one is, what is the generating function for the constant sequence like 1, 2, 3 and so on. So for this sequence, we have the generating function name as f of x. 1, 2x, 3x square, 4x cube plus and so on plus n plus 1 x power n plus and so on. Why? Because we are going to write this as 1 minus x whole power minus 2 because of the binomial expansion. It can also be written as 1 by 1 minus x whole square. Now the third formula for the generating function of the sequence of the form 0, 1, 2, 3, 4 and so on is the generating function name taken as capital F of x, 0, 1x plus 2x square plus 3x cube plus and so on plus nx power n plus and so on. Now 0 can be eliminated because 0 plus anything is anything. That's why here the values are 1x, 2x square plus 3x cube plus and so on. So now we are going to take a common x of 1 plus 2x plus 3x square plus and so on plus n plus 1 x power n plus and so on. So x of, what is the value of this? In the second formula, we have the value of this as 1 by 1 minus x square. That's why x into 1 by 1 minus x square is equals to x by 1 minus x whole square. Now the fourth formula is the generating function for the sequence of the form like a, like 1, a square, a cube and so on is 1 plus ax plus a square x square plus a cube x cube plus and so on plus a n x power n plus and so on. So this can be written as 1 minus ax whole power minus 1 by using the binomial expansion. It also can be written as 1 by 1 minus ax, 1 by 1 minus ax. So these are the some standard generating functions for the sequences. So what are the uses of generating functions? Now generating functions can be used in following cases. One is, generating functions can be used for solving recurrence relations, and these can be used for proving some the combinatorial means combinatorial and combinations identities, and for finding the various kinds of counting problems. Now we are going to learn important note which are used to find the generative functions of different sequences whose nth term is an plus 1, an plus 2, an plus 3 and so on like this. Now coming to the note here, let g of x is the generative function of the sequence an whose nth term is an. So that's why g of x can also be written as, already we know the generative function general form like this: a0 a1x plus a2x square plus and so on plus anx power n whose nth term is an. This is general form, already we seen earlier in this video. Now we can find the generative functions of the sequence whose nth term is an plus 1, an plus 2, an plus 3 and so on as follows. Now we are going to find the generative function for the sequence an plus 1 means whose nth term is an plus 1. So now we use the generative functions as usual. Here g of x is equals to a0 a1x a2x square plus and so on plus anx power n plus and so on, and take a0 value means first term to the left hand side of this generating function. Now it can be like this: g of x minus a0 equals to the remaining terms in the right hand side or a1x plus a2x square plus and so on plus anx power n plus and so on. Now we are going to take common x of right hand side of the terms, x of a1 plus a2x plus a3x square plus and so on plus an x power n minus 1 plus an plus 1 x power n plus and so on. Here the coefficient of x power n is an plus 1. That's why g of x minus a naught by x. G of x minus a naught by x. Here x is taken into this side by x. a1 plus a2x plus 3x square plus and so on plus an x power n minus 1 plus an plus 1 x power n plus and so on is the generating function whose nth term is an plus 1. Okay. Like as now we are going to find the generating function for the sequence an plus 2 whose nth term is an plus 2, like this. So now we take two terms by using the equation number 1 we are going to take the another term, means a1x, to the left hand side of this equation. Then the g of x minus a naught minus a1x is equals to the remaining terms of the equation number 1, that is a2x square plus and so on plus an x power n plus and so on. Now we are going to take common of the right hand side of the values x square. Then the right hand side values are x square of a2 plus a3x plus a4x square plus and so on plus an x power n minus 2 plus an plus 1 x power n minus 1 plus an plus 2 x power n plus and so on. So here here x power n coefficient is an plus 2. That's why g of x minus a naught minus a1x by x square is the generative function for the sequence whose nth term is an plus 2. Okay. And similarly we are going to find the generative function for the sequence an plus 3 by using the above case, that is g of x minus a naught minus a1x minus a2x square by x cube is the generative function for the sequence an plus 3 whose nth term is an plus 3 and so on.